All right. Thank you, everyone, so much for joining us today for today's Lunch and Learn. I am Erin Creighton. I am the Adult Services Department Head and Assistant Branch Manager for the Fredericksburg branch of the Central Rappahannock Regional Library. Today, I'm very happy to be joined by Jon Bachman, who is a naturalist and historian who's here to talk to us about the iron industry in Virginia, which has kind of got like this very interesting, fascinating history. Thank you so much for being here today, Jon.
Hey, no sweat. The so I'll just go ahead and say next slide and that stuff like that. Hey, no, I tell you what, go back. Yeah, let me warm everybody up here. The iron industry in Virginia. Didn't know much about it. Knew there had been. Have had the opportunity to visit some of the sites that you're going to see, and the bigger picture blew me away. The iron industry in Virginia is as you'll see, has been overlooked historically. It's just going to pass by. But for those people to dig into it and to understand, no pun intended, those people that try to understand its impact on our society in Virginia, it's crazy. This is an important one, guys. Okay. Next. Before we run on, the photos that I have selected, I may pause on a little bit longer for you guys that are watching to focus on the different pictures. And again, if you, I know that Erin has my email, and if you have questions or anything like that concerning any of this, you can send them to her, and she'll forward them to me. Okay, next slide. Okay, so the story begins to last year. And for 2 months, my wife and I waited out of real estate realities of early 2025. We're trying to sell our house, never did, which is fine. As I told Erin earlier, hey, we love our house and we're back in it. But we stayed in this cabin near a place called Laurel Run, which was in western Shenandoah County, Virginia. Really cool place. Next slide. And let's start with the little blue arrow up there in the upper right. You can see that is where we were. You can see how close we were to the West Virginia line there, Shenandoah County. Within a few hundred yards of the cabin that we had stayed in, there was this historical marker that indicated this was the Liberty Furnace iron plantation, 1822. And I thought, whoa. And some of the pictures, the picture of the mill-like building, that is at the Liberty Furnace. There was a historical picture there, etc. Okay, so we were there waiting out the real estate crisis while I started exploring this whole iron industry. Next slide. Well, an iron plantation, excuse me, was an industrial complex comprising hundreds of enslaved people, indentured servants, and free laborers. Their work was notoriously difficult and dangerous, encompassing tasks like mining ore, felling timber, and operating fiery furnaces. Take a look at the pictures. That is an iron plantation. And you can see how extensive the building and structures were. Next slide. And this is cool because it shows you where the natural iron deposits are in Virginia. They're pretty much located in the Blue Ridge and in the Allegheny Highlands. To the left, every one of those little brown dots there on the Virginia map represents a location for mineable iron in Virginia. That's pretty interesting. Next slide. Okay, well, we know that Alexander Spotswood's 18th century ironworks, known as Tubal Furnace, was the first fully equipped and archaeologically identified iron furnace in colonial Virginia. Those artifacts that are there, those are the bottom one is a chisel. And then there was I found it associated with that the shells and things, because limestone's used for it, and the shells were used to harvest the lime necessary for the smelting process. But the other things laying on that sheet are slag. Okay. Anyway, so Spotswood constructed this furnace in 1717. It's pretty early in Spotsylvania County, and this large-scale industrial operation is primarily powered by the enslaved people. That photograph of that hole that you see in the bottom there, that's the entrance, one of the entrances of the airway necessary to supply air to these huge furnaces. Next slide. Yeah, today the Virginia plantations, iron plantations, are all but forgotten. Only visible now are the remnants of that industry scattered across western Virginia primarily, though the Spotswood furnace is in Spotsylvania County, pretty close to us. Next slide. Okay, let's start simple. Where's iron come from? Okay, that's a blob of iron ore. Within the first few minutes after the Big Bang, right, the universe's initial matter formed. All the universe's initial matter formed at that time, with hydrogen being the simplest and most common element that would combine to form all the other elements that we are associated with in our current universe. Next slide. The rapid expansion and cooling of the early universe prevented widespread fusion into heavier elements. So most of the primordial matter remained as hydrogen. Next slide. A star consumes hydrogen through nuclear fusion. Yeah, well, nuclear fusion is the reaction in which two or more atomic nuclei combine to form a heavier nucleus. Okay, I think a lot of us picked that up in basic chemistry and some other high school classes and maybe earlier. Fusion, nuclear fusion. Next slide. The general result is the same. 4 hydrogen nuclei combine to form a single helium nucleus, releasing a tremendous amount of energy. A star's mass determines how quickly it consumes its hydrogen fuel. Sun-like stars have a much more moderate pace of fusion, allowing them to burn hydrogen for billions and billions of years. At the present rate, our sun, which is about 4.5 billion years old, will continue burning hydrogen for another 5 billion years. And as the star runs out of hydrogen, its core shrinks or contracts and heats up, enabling the fusion of heavier elements. And you can see that in this diagram of the sun, where the different elements are forming, and you'll notice at the very bottom, iron ash at the center of a star. So the fusion operates from the inside out. So a star fuses hydrogen, right, into helium. Then the helium is fused into carbon, and the carbon into oxygen, the oxygen into silicon. And that then finally silicon fuses into iron at the heart of a star. Next slide. Fusing silicon into iron is the final heat-releasing reaction. Iron is the final element stars produce before they die. And the core collapses into what most of us have heard of. The core collapses and then explodes into a supernova. The immense energy from the subsequent supernova explosion creates and scatters elements heavier than iron. So other elements are formed at the time of the exploding nova. That's where gold comes from, platinum, uranium, whatever, all the other elements across the galaxy and throughout the universe. So, but iron is the one that produced in stars. The rest of the elements formed after and during the supernova event. And over billions of years, elements like iron are scattered by dying stars. The iron that forms our planet's core was part of the original building material of the Earth, while smaller amounts arrive continuously via meteorites. Because iron is one of the heaviest and densest elements, it was pulled by gravity toward the center of the planet, effectively separating from the lighter silica-rich material. So gravity is the big deal here, right? And the iron that was originally the core of stars is now migrated through gravity to the center of our planet and other planets, period. Iron, center of the planet. Next. 85 to 90% of all iron on Earth is found in the planet's core. The remaining 5% or so is found on the Earth's crust, making it the fourth most abundant element in the crust. Iron also arrives via meteorites. NASA figures that about 48.5 tons of meteoric material falls on Earth, wait for it, every day. 48 tons of meteor, and you can collect it, by the way. Very interesting. I might do another little video about collecting your own meteoric dust. It's pretty cool, and you can do it. Next slide. Any iron deposits found on Earth now are the result of billions of years of erosion and tectonics. And the red color we associate with rust and things like that is simply a chemical reaction of water and iron that gives it that red color or reddish color. Okay, so enter man. The first metals used by prehistoric humans were those found in pure natural form, gold and copper. As mentioned, meteoric iron. By the way, the Egyptians called meteoric iron black copper from heaven. I thought that was pretty cool. And in the Great Lakes region of North America, the indigenous peoples there have been working copper for thousands of years into tools and weapons, as it says, as far back as 4,000 BCE, before Common Era. This is cool. The earliest humans used meteoric iron that literally fell from the sky. Those are artifacts. There's obviously a spear point or something like it that's made from meteoric iron. That's crazy. Little ring. I don't know what that is. The Hittites were among the first known people to smelt iron from its ores. They developed techniques for purifying it by heating ore in what is called bloomeries, which was a closely guarded secret by the Hittites for centuries. It would not be until humans could prolong temperatures, and prolonging the temperature of at least 2,800 degrees Fahrenheit, that iron could become fluid. Now, they didn't start this immediately. This was, again, learned by collective reasoning and stuff by different cultures over many hundreds, if not thousands of years. But the key element was you had to have a fire hot enough to melt the iron, to separate it from the iron ore. These temperatures could be reached by using, as I mentioned, something called a bloomery. That's a bloomery. Okay. And that's bloomeries. Iron bloomeries were not discovered by a single person, but developed through a gradual process of trial and error in different cultures around the world. So that's what they look like. And the oldest known worked iron artifacts are beads, meteoric iron beads, that, and I should have probably put this slide in a little earlier, but the Egyptian, 5,200 years ago, meteoric iron was hammered into beads. That's what they did, is they hammered it into tiny little thin sheets and then rolled the sheets like you would roll like little tiny pieces of straw, like drinking straws or something, like little, and then sometimes squeeze them together to make beads and stuff like that. It's crazy. Next slide. Africa is considered one of the earliest, if not the earliest, independent centers of iron smelting technology. Remember, the key to it is the 7,500 degrees. Yeah, about 2000 BCE, archaeological sites in Nsukka region of Nigeria produced evidence of bloomery-styled furnaces. I'm not exactly certain when I looked these pages up or looked up. That is, I guess, the remnants of an earlier ancient Nigerian bloomery. Separating the iron from the ore, that's called smelting. Smelted iron objects began to appear in Mesopotamia, Anatolia, and Egypt, or somewhere between 1800 to 1200 BCE, before the Common Era. And in India, early iron implements have been found in archaeological sites in the Gangetic Plain. That just blew me away when I found out how extensive this was. Next slide. Culturally and historically. Because early bloomeries did not produce enough heat, right, 2,800 degrees, etc., to fully melt the iron, workers had to repeatedly reheat and hammer this bloom, which is the blob of iron that you get when you separate it from the iron ore, to consolidate it, meaning, to squeeze it together. And so that's when you see these blacksmiths hammering pieces of iron like that. What they're doing is they're driving out the impurities when they beat it. And it's called annealing when you hammer metal to strengthen it or to drive out any of the, as I said, impurities that might be on or in the metal. Next slide. The blast furnace, originated in the 5th century BC in China. That is amazing. And now, a blast furnace, which many of you have heard the term, is a large, tall, cylindrical industrial furnace used to smelt iron ore and to produce liquid iron, known as pig iron. The blast in its name comes from the continuous supply of hot, pressurized air blown into the bottom of the furnace to intensify combustion. It's like a bellows. You squeeze the bellows and you force the air, and you probably have seen how that increases the combustibility of material. Next slide. A blast furnace works by using heat and chemical reactions to continuously convert iron ore into molten iron. It's also known as hot metal. And these are interesting pictures that show you different blast furnaces around the world. Some very ancient, some more modern, as you can tell. Raw materials, are loaded into the top of a towering refractory line shaft, while a blast of hot air is blown into the bottom. This creates a countercurrent flow of descending solids and ascending hot gases, which drives the entire process. Iron ore and charcoal are heated together with bellows, providing air to achieve high temperatures. Charcoal is used in iron making because it burns at high temperatures necessary to create the heat needed for smelting. Iron making comes to the Virginia colony. The first iron production facility in English North America was the Falling Creek Iron Works. The Falling Creek Iron Works archaeological site is located in Chesterfield County, Virginia. The iron ore for the Falling Creek was a type of limonite known as bog ore or bog iron, which is found in local swamps and bogs in the Virginia coastal plain, which is that section affected by tides, otherwise known as the Tidewater area of Virginia. Next slide. Constructed in Chesterfield County by the Virginia Company of London, the operation included a blast furnace that produced iron in late 1621 and early 1622. The entire operation, though, was destroyed during a coordinated Powhatan attack on March 22nd, 1622. It was not until the early 1700s that Virginia's iron industry was successfully reestablished. And in 1723, Spotswood's German indentured servants and African-American slaves had constructed a blast furnace called the Tubal furnace. By the way, Tubal, the name, is a biblical name referring to a descendant of the seventh generation of Adam that apparently was called the father of blacksmithing. Hence the name Tubal, called the Tubal furnace, named after biblical character Tubal Cain. Spotswood would ship 23 tons of pig iron to England as ballast. Ballast is used in the bottoms of ships to keep them upright. By 1739, the furnace lay in ruins, though, and Spotswood's dream vanished of developing a, as it says, vibrant iron trade. That sort of died in pretty early 1739. And that's a picture of what's left. But by 1732, Virginia had several successful furnaces and forges because iron ore is pretty common in Virginia. And it became obvious that if you could, this is big business, huge business. Iron production, you'll see. Next slide. Other ironworks, including the one here in Stafford County, known as the Hunters Ironworks, thrived for a time, and then they too faded. Up toward Woodbridge, Neabsco Ironworks begun around 1737, and these are photos of the archaeological site further up near the Woodbridge, Virginia area. And they supplied military armaments and cannonballs and all kinds. And they had something called a shot tower, where they would drop molten iron from a distance of 100 feet, 60 to 100 feet. And as it fell, it cooled and formed little droplets, and they're pretty uniform, and they were used as musket balls. And this was called a shot tower, where they would pour molten iron, let it drop, and let it form naturally into little bowls. Pretty cool. Next slide. The Occoquan Ironworks was powered by the Occoquan River and fueled by charcoal from thousands of acres of forest around it. Now, those pictures are not low. Of course, that's the Occoquan up there, but those beehive-like structures there, those are charcoal kilns. And there would have been those, I don't know if they're up there in the Occoquan. There's a regional park in Fairfax County that has in Occoquan that has extensive displays and replicas and the actual structures of the iron production. So if you're getting into this, take a drive up, I guess 123 and to Occoquan, and then swing over and look at the Fairfax County Park there, which has extensive archaeological references to the iron making. And that is the story of the iron industry.
Well, thank you so much for joining us today, John. That was enlightening as always. That stuff about meteorites dropping all that iron, that is crazy. That was
I know. By the way, you can collect your I'm thinking about actually, I tried this, collecting meteoric iron one time as a science fair experiment for my son, right? And we collected some. We spread it's constantly raining down in the atmosphere.
Very cool. Well, thank you very much. We really appreciate it, and we'll see you next time.
You got it. Have a good one.